Welcome to American Cannabis. I'm your host, Ellis Smith, and today we're going to be speaking with Sean Sangster of Fluence. Welcome, Sean. How are you today?
I'm doing well, Ellis. Thank you for having us.
All right. So I've seen Fluence technology with your LED lighting for cannabis for many, many years, and I'm super excited to get you guys on today. I think I heard you mention that you guys haven't done too many podcasts as a company, so I'm excited to be one of those first ones to help get the word out there what you guys are doing. So thanks for the opportunity on your end as well for coming on today.
Awesome. And we appreciate the opportunity to share what we've learned and some of the experiences that we see with some of our growers. So without further ado, I'm going to jump into the presentation. And like Ellis said, my name is Sean Sangster, and I'm going to be talking to you guys about adjusting your environment and how lighting affects cannabis production. My name is Sean Sangster. I'm a project manager for the Hort Services Department at Fluence by OSRAM. And my background is in agronomy as well as supply chain management. I also have hands-on experience over the last decade as a grower for both commercial ornamentals and commercial cannabis production. So why are we here? So today, guys, we're going to be talking about a few key things and some things to remember when producing cannabis. And so we're going to be talking about light. We're going to touch on yield and the correlation between those two. And then we're going to talk about the bottom line and how we can take these three things and affect that. So the presentation outline, we'll be going over and evaluating different horticultural lighting. We'll touch on some key terms. We'll go through a case study with one of our customers that we did and how their lights affected their yield. We'll go through the cannabis scheduling. We'll talk about DLI and how to think of it. Then we'll shift gears and go into adjusting your environment. We'll talk about limiting factors. We'll dive deep into the integrated root zone management. We'll touch on some HVAC considerations. And then we'll finish off talking about VPD and how to manage HVAC. We'll talk about our key takeaways and then go into a Q&A session. So before we can go in and talk about lighting, we need to talk about some of the key terms that we use to describe horticultural lighting. And the key terms are displayed for you all here. We have PAR, which is photosynthetic active radiation. We have PPFD, which is photosynthetic flux density. And we also have DLI, which is your daily light integral. So let's dive into PAR, photosynthetic active radiation. And so PAR are the wavelengths of light that are used to drive photosynthesis. These wavelengths usually range from 400 to 700 on the photosynthetic electromagnetic spectrum scale. As you can see, it's displayed here. Next, we'll dive into PPFD, photosynthetic flux density. And so in order for us to talk about PPFD, we need to first dive into cannabis response to light, and then we can tie PPFD into that. And so the two main responses that we see to cannabis is both growth and development. And there's three parameters or properties of light that dictate that, which is light quantity, light quality, and light duration. In other words, intensity, spectrum, and photoperiod. The interaction between these three properties elicit both growth and plant development responses, such as plant biomass accumulation, morphology, as well as flowering. But the main thing that we need to focus on today, and what I really want growers to take home from this presentation, is light quantity or intensity, which equates plant biomass. In other words, PPFD, our light intensity. And so why is this important? Well, there's two reasons. It's because it's measurable and it can directly tie to the financial performance of a business. And how so? And that's through the manipulation of plant biomass. Let's dive a little bit deeper and talk about PPFD. And so here's a diagram that shows a light source, whether it be the sun or if you're in an indoor sole source lighting setting, and there's a time at 10:30 in the morning. So you as a grower, you walk into your production environment with this quantum sensor or a light meter, and you're going to check light levels. This is what we call PPFD, an instantaneous reading that you take at one time during the photo period. So how does this compare to DLI? Well, from the diagram you can see here, we have a duration of time. And through this duration of time, which we consider the photo period, there's photons that accumulate on the surface or the canopy of the plant. This accumulation of photons over this period is what we consider DLI. And so it's important for growers to understand that, and I'll show you why in later slides. So how do you calculate DLI? Well, it's important for growers to know that there's two parameters and an equation that they need in order to calculate DLI for their given crop. And so the two parameters would be PPFD, like I just showed you in the previous slide, which would be intensity, and then the photo period, which would be the duration of the light. And so whether it's an 18-hour, which we consider the long day, or a 12-hour photo period, which we consider the short day, you would plug these parameters into this equation, and then it will compute DLI for the grower. So let's look at the impact of PPFD on yield and revenue. So this is a graph, and this is a study that we did with one of our customers, Outco, a couple of years ago. And they had 5 different treatments, as you can see, the different PPFD levels at the bottom of this graph, along with the corresponding DLI levels that they get for each light intensity, ranging between 400 and 1200. There was 4 treatments that were LED, and there was 1 HPS treatment. But we saw a trend amongst all treatments, and that is what we display right now. And so there's an upward trend when going from a 400 to a 1200 PPFD, or in other words, a 17 DLI to a 51 DLI. And what the trend was is an increase in yield. And so as we added more light to the environment, we in turn received more yield, which is huge for the bottom line when you're in an environment where margins are where they are today for cannabis. So some of the things that we saw, which was interesting from the data, was that for every 0.8% increase in yield, there was a 1% increase in DLI added. So from 400 PPFD, we added 66% more DLI, and in turn got a 53% increase in yield to a 1200 PPFD, right? So the big takeaway from this study for us was that an increase in light gave us an increase in plant yield. That's very important for growers to understand. Next, let's dive into DLI. So let's go over the cannabis typical schedule, and then let's look at DLI and how to manipulate it over the schedule. So as you can see here, this diagram shows the different stages of plant growth for cannabis, and then accompanied with the typical schedule for each stage. And so as you can see, we'll start off with clones, which will be dictated by an 18-hour photo period. This is what we consider the long day photo period, followed by the vegetative cycle, or the vegetative bulking cycle, which we see that lasts anywhere between 2 and 3 weeks. And then going into the 12-hour short day cycle, where we initiate flowers. Let's look at DLI and how photoacclimation can be used. And so basically back to the same diagram that I showed you in the previous slides, but this time it's now accompanied by recommended PPFD levels per stage, as well as the corresponding DLI that you would get if you were to run these light levels for cannabis. And so let's go through it again. Looking at the cloning phase, we're at anywhere between 80 and can finish off upwards of 300 PPFD. Moving into the vegetative cycle, Most growers are starting around 250 and ending anywhere between 400 and 650. This is huge now when transitioning from vegetative to flowering, because now we're switching the photo period and creating a dip in DLI. This is important because, as I showed you in the outgo slides, DLI is important to yield. And so in order for growers to overcome this, depending on your cultivars, there's two recommendations that we have. Either switching, when you switch over to the flowering cycle, go in under very high light intensities. When I say very high, I'm talking about 950 and up, or use the strategy that we're talking about today, which is photoacclimation. And so this is a buildup that growers can utilize in their grow to maximize the light absorbed by their plants over time, right? And so what we recommend to growers is that the first week and a half of flower, if you come in at a 650 ppfd level, our recommendation would be to increase light levels on a daily basis of anywhere between 25 to 50 micromoles per day for the first week and a half. And as you can see from the graph below, this is what was done in this strategy, and it allowed this grower to push past DLI levels previously seen in veg. Now let's shift gears and talk about adjusting your environment. So let's look at high ppfd and other limiting factors. Awesome. So as you all know, up until recently, light has been one of the major limiting factors when it comes to plant production in either a greenhouse or an indoor setting. With the advancements in sensor technologies, dimmer technology, as well as LED technology, this has allowed growers to no longer have light or fear light as a limiting factor when it comes to plant growth. In that case, we need to look at the other parameters that influence plant growth and development in the production setting, such as the ones displayed before you, temperature and CO2. This graph shows the relationship of temperature on CO2, and as temperature increases, so does the assimilation of CO2. Growers need to be aware of this because even though you're running under high light intensities, if these other parameters are limiting or not optimum, this can be detrimental to plant growth. Now let's take a look at light saturation and CO2 and how this influences photosynthesis. And so this graph will also show you the limiting factors that light plays on CO2. Like I said, under highlighted conditions, they're going to be running different parameters. And so as you can see here, when you're starting to go above 1,000 ppfd in light intensity, it is crucial for you to also supplement these conditions with high levels of CO2. Growers can also look at this graph in another way in terms of the different stages of crop production. For example, when we're in propagation and we're running light levels between 80 and 250 ppfd, you can see that there's not a need to pump 1,000 parts per million of CO2 in that stage of development. And so this can also help on the bottom line where you can say and strategize with your team and say, look, we only need 400 or less in propagation, and so on and so forth for veg and flower. Now let's talk about high ppfd and integrated root zone management. So before we dive into the physiology of roots and how they interact with under high light conditions, we need to take a look at the overall scheme of what's going on in the below ground parts of the plants. And so the major factor here would be transpiration. And transpiration is dictated by the pace of photosynthesis, right? But there's also key things that growers need to take into consideration here as well. And what we've seen is under high ppfd conditions, transpiration will continue to increase even when chlorophyll becomes saturated by light. So that's important, guys. So even when you're under high light intensities, you're still going to have transpiration rates that may exceed the photosynthetic rate of the plant. And there's going to be some things that need to be adjusted for that, and we'll talk about that now. So let's talk about the root system. And so this is also a reminder for most growers, but for those who may have forgotten, it's always good to get a refresher. And so let's take a look at the roots. And so the roots have two main things that go in, which is nutrients and water, and then a combination of things that are secreted into the root zone environment. This exchange, though, under high light intensity tends to be elevated. And the consequence of this and a side effect of this process being elevated is that pH will change. And so growers, I understand that we have schedules that we check EC and pH maybe on a daily basis or a weekly basis, but it's crucial to understand that pH and EC checks are crucial for the success of your plant when under high light intensities. Like I said before, pH can be affected by high light intensity due to the exchange of the root zone exudates and nutrient uptake. And so growers using this chart to understand where their pH needs to be for the optimal nutrient uptake is crucial. What we see in cannabis to be the range of pH that is successful for most growers and most cultivars is anywhere between 5.5 and 6.5. Another key thing for growers to remember is that under high ppFD, it's recommended that growers use low EC, low volume, and frequent irrigation strategies to avoid drought stress, stomata closure, and yield reduction. So here are some solutions growers can implement if they run into some issues in the root zone environment. And so one thing that we suggest to our growers is that they can leach anywhere between 15 to 20% of their nutrient solution out of the root zone at each irrigation, measure EC of entering and exiting nutrient solutions, and then spot check the crop for pH and EC checks using the pour-through method. Now we'll touch on some HVAC considerations. Alrighty, and so in order to understand what the HVAC system is managing, we need to understand what it was designed to manage. And basically how systems work is through managing sensible and latent energy. To break this down into simpler terms, we most associate sensible energy with heat or temperature. So if you walk into a cold building from a hot outdoor setting and you feel that coolness on your skin, that's what we consider to be sensible energy. Next is latent energy. And we most associate latent energy with moisture and humidity. So imagine walking into a sauna and it's full of water vapor in the air. This water vapor is considered latent energy. And your HVAC systems in a production setting will be managing both of these energy sources in order to create optimal conditions for your plants. So let's look at an HVAC setting and how it would interact under different lighting sources. So as you can see from the top diagram, we have HPS setup and an LED setup. And some of the main key differences that you'll see in this diagram is that the supply duct that comes in, or the return duct air for the HPS setup, is showing signs of cool air. Well, it's not necessarily cooler air. This air is cooler in comparison to the air that would need to enter in an LED room. And why is that? Well, there's two reasons. HPS emits infrared light, which is seen on the plant level as heat. So these plants are generating heat under an HPS light. In an LED setup, there's no infrared light, and there's a lack of heat that is perceived by the plant. And so it's important for the HVAC system in an LED setup to compensate for that missing energy or that infrared heat that you would get in an HPS setup. So let's look at how does an HPS affect the greenhouse setting. So when the lights turn on, or light intensity increases in an HPS setup, we also get an increase in air temperature. This is followed by a reduction in humidity, and then we get a response from our VPD in irrigation demand, as well as our evapotranspiration turns elevated. This is what we see in a typical HPS greenhouse. But how does that differ when we have an LED greenhouse? And so what we see here is as light intensity increases, air temperature is relatively not significantly impacted by the light. And so what happens is we get an elevation in photosynthesis, which increases our relative humidity in the space. This can cause VPD, irrigation demand, and evapotranspiration to be reduced, thus reducing the yield. And so how does a grower manage these environmentals? They can use a VPD chart for cannabis. And I say that because there's many VPD charts. There's ones that you can find for tomatoes, cucumbers, all different crops, and they will be different to the crop. And so it's very important to use a cannabis VPD chart. When applying VPD to the grow environment, it's good to understand that if you're too high or you're too low, you can see some detrimental effects onto the plant, such as high water transpiration and an increase in relative humidity, or nutrient deficiencies and stresses on the plant. This guide can be found in our cannabis cultivation guide that'll be out to the public next month. Here are some of the humidity ranges that are typical for cannabis that we see, and so most growers are going to want to work with their HVAC provider or the environmental systems provider in this range, as well as in the temperature range, to lock down the VPDs that they need to manage their environment. Nice. And so now let's go through a recap. Some key takeaways, and then we'll head over to the Q&A. And so we did an overview on horticultural lighting. We talked about how light intensity is key to success. For every 1% increase in DLI, there's a 0.8% increase in yield. It's important to measure light intensity, guys. I can't stress that enough. That is going to be the key to yield, as well as operating in the green when it comes to the revenue. PPFD is instantaneous. DLI is over a total time, right? And so understanding those key concepts and being able to manipulate those to hit your environmental settings is key. We talked about adjusting your environment. We talked about some of the limiting factors on yield that can be presented in a growing environment. We talked about checking pH and EC very often. And then using a cannabis VPD chart to nail down the parameters that are most crucial for your environment. And then we talk about downloading the Fluence Cannabis Cultivation Guide. This will be available in March via our website, where you can find it here. Thank you, everyone. And now I'll turn it back over to Ellis for Q&A.
Sean, thanks so much. That was a load of information. We've got quite a few questions here coming in from our audience. And so if you're ready, we'll fire away with these, as we've got quite a few to get through. The first one is, under high PPFD is in flower stage, how frequent is, in quotes, frequent watering? So give a little explanation what you mean by frequent watering.
Absolutely. And so this would start with working with your irrigation provider and understanding the watering rates of the plant. And it's always going to depend on the pot size, but what we see typically in cannabis is guys going anywhere between 1 liter per plant per day, and then breaking that 1 liter over the photo period of the plant. So say in flowering we have 12 hours, there would be 12 watering events, ranging anywhere between 2 and 2.5 ounces per plant per watering event. And so that's what we mean when we talk about frequent watering. Instead of just a watering in the morning and then maybe a midday watering, breaking it up to give the plants a chance to absorb what's put in.
All right, great. Okay, here's the next one. What is the ideal PPFD in flower rooms without CO2 sublimation? supplementation? There must be a tipping point, no?
Yeah, and so what I like to tell my growers is once we start to hit ranges above 800, 850 ppfd, it's going to be crucial to get CO2 in there. That's it. The plants, you're doing two disservices to yourself. One, the plants are going to need it, obviously, because of the restriction of CO2 not being put in there. And then the other one would be that under high light intensities, CO2 will become limiting to the yield, right? And so staying under 800, 850 would be ideal to not have elevated levels of CO2 or just ambient levels, right? Greenhouse levels where you're not supplementing anywhere between 400 parts per million is fine.
Thank you. Okay, here's another one. Does VPD vary from plant to plant and leaf to leaf? If so, how do we determine appropriate adjustments to stay in the Goldilocks zone for VPD for a cannabis facility?
Good deal. And so what I like to tell guys is that, VPD is an indicator. It's not a direct measurement of transpiration in the plant, right? And so I like to manage the environmentals and say, look, what's my temperature need to be? What does my humidity need to be for me to be successful? And then use those two data points to correspond a VPD, right? And then once I get that corresponding VPD, then I can say, all right, look, for my future grows or for any cultivator that's coming in here after me, this is the VPD range that you should be targeting based on the environmental set points of temperature and humidity.
Okay. When discussing temperature of what? Does this mean air temperature or leaf temperature?
Well, in the case of VPD, you want both, right? You want to understand what's the air temperature of your environment, and you want to also understand what the leaf temperature is, because they're going to be different under different lighting sources. As I explained with the whole infrared and radiant heat, with HPS, we don't have that in LEDs. So what growers can do is to combat that with raising their temperature in the room, which their area of temperature in the room, which will thus elevate the leaf surface temperature. And they can use an infrared thermometer gun to check that to make sure that they're within the optimal ranges.
And someone's asking, do you have an optimal leaf surface temp? I think that's kind of a loaded question once again.
Right. So depending on all other parameters, if other parameters are optimum, such as CO2, moisture management is correct, nutrients are optimal, I like to see an elevated leaf temperature anywhere between 78 and 80. Right around those two temperatures, when we see an LED under high ppf conditions, is the plants of the cultivars that can handle these conditions do really, really well. Obviously, you're going to have cultivars that don't like that degree of temperature, but the ones that do show really good promise in terms of overall plant health.
Okay. How do you avoid stems from tanning into purple color under high ppfd?
Oh, that's a good question. For me, I've only seen purpling stems not under high ppfd conditions, but when either there's a nutrient, something going on with the pH or the EC, so there's a nutrient component to it, whether it's maybe low phosphorus or high phosphorus. One of those elements may be to part in that, but mostly I also see it under cooler temperatures in the either the greenhouse or in the indoor production setting. And so managing your temperatures, I think, can help avoid that. And then there's some cultivars that's just natural for the cultivar for that to happen. And so understanding and knowing the date or the week in which those color changes are happening, and then managing the environment in correlation to when you're seeing these responses in the plants can give you a really good insight to whether it's the genetics or whether it's the environment playing a role on it.
Okay, this one has multiple questions from this one person here, so we can get through all of them. What are your thoughts on running UVB light supplemental in flowering, as well as supplemental blue spectrum in veg in the last part of flowering? Is light intensity more important than light spectrum ratios when it comes to yield?
Good question. So let's answer let's break it down and answer the first part. And so the UV talk right now, it's very interesting in the lighting industry right now, and especially in cannabis, as UV can be used as an IPM application or a booster for cannabinoid responses. The research right now is still in its infancy for the cannabinoid responses in plants to UV. I think there's a lot more research we need to do to make sure that's a definite. But if we're looking at UV for IPM, then that's another question for is it safe for the people that I have working in the environment? When will I be dosing my plants with UV? It's a whole strategy that needs to be talked about. Is it necessary to actually have UV in the growing environment or in the post-harvest environment? And so I think there's some questions that still need to be answered in the case of UV, because there's belief that even the blue photons in the lower range of the electromagnetic spectrum can elicit the same response that we're seeing from UV. And then the second part of the question, Ellis, can you please repeat that part?
Okay, so is light intensity more important than light spectrum ratios when it comes to yields?
And so to answer that question, that's a really good question. But as we're seeing in cannabis, yes, that's the case right now, as light intensity is trumping both the spectrum talk. And so that we're seeing that at universities. I know Bruce Bugbee is doing some research on that now, and he's in his studies that he's seeing that light intensity is in fact trumping spectrum. But I still believe that the spectrum plays an important role in the morphology of the plant. But when we talk about yield response in the plant, it is intensity that trumps.
Okay. How do you deal with the missing radiant heat with LEDs?
That's a good question, and we get that all the time from our growers. And so what we do is, what we tell them to do is elevate their, and this is, it's really important to understand it, especially if you're in an indoor environment. If you're able to have cultivars that can run at a higher temperature, aerial temperature, it's more conducive to do that with an HVAC system under LEDs, right? So running a warmer aerial temperature in there can equate to lower HVAC costs, just due to the fact that the dew point of that air that's going through the duct will not be as low as it would be for an HPS setup, for example, right? So if you run a higher temperature and a moderate humidity under an LED setup, we see a lot lower HVAC costs, as well as a better plant response. And so what growers can do is use an IR gun to check their leaf temperatures at the top of the canopy to make sure that they're within optimal range.
Great. Evapotranspiration-wise, does using LED change the right VPD to aim for?
Good question. And I think it would be better to look at it from the other way, right? And so we understand that under LED technology, we're going to be able to drive high light intensity due to the advancements of it. And VPD, we need to look at VPD as an indicator, right, and not a direct correlation of transpiration. The VPD is just measuring the amount of water that the air can hold, or how much is already in there and how much more it can hold. And so aligning your temperatures and your humidity for success, and then using that VPD number as an indicator or I would say a parameter to look at, to check when you're going through your environmentals to make sure you're within the right range, which is good. But I think growers need to look at temperature and humidity, and then the corresponding VPD to that temperature and humidity.
Okay. This is a question that also I'm going to make a reference to, that Cannabis Tech will be having a webcast on Thursday based on this question on raising and lowering your lights. So the question is, do you recommend raising and lowering your lights with LED or HPS?
I would not, right? And so, and my reason for that is because, you know, when you're in a production setting and you have all these things going on a daily basis, where you're managing people, you're managing your nutrients, you're managing all the inputs that go into plant production, and you're having guys having to touch lights and move them up and down, or you have them on these pulley systems that move them up and down. I don't believe it's necessary. I believe that, you know, proper pre-planning can help to avoid all of these operational bottlenecks, which I would consider this as a bottleneck. If I have to pull somebody off of trimming or, you know, pruning or taking care of some plants to go and move lights up and down, which I could have just planned for with my lighting provider and say, hey, look, this is what I want to hit, and we can use dimmer technology and sensor technology to control the light levels of this, then I think that's a better use of the human capital that goes into plant production.
I agree with you there. What are the main causes of light bleaching?
Oh, great question. Oof, really good question. And so we did some trials with a couple of our customers, and we saw some photo bleaching in some of the treatments that were competitor lights. And so I won't go into who lights there were, but what we did see and what we did find out, it's correlated with the xanthophyll cycle, right? And so yeah, I know it goes a little bit deeper than the everyday growing, but for those who are interested, understanding the xanthophyll cycle and how the chlorophyll A and B get overloaded by maybe some narrow band spectrums, and understanding that there's a de-epoxidation of the xanthophyll, which allows for photo bleaching to happen, right? And so there's the cells are overloaded with photons, and then they can't dissipate the heat. And so this results in what we see as the flower buds turning white, and thus rendering them unusable or unsellable for shelf flower.
Sure does look pretty cool, though.
Yeah, it depends. You know, if you got a good marketing campaign or something like that. But I'm not going to be buying that one. I can tell you that.
That's for sure. Albino cannabis, there's not a big demand for that.
No.
All right, I'm having, this is a direct question with, I believe, your lighting here. So I'm having a huge problem with acclimating the plant going under the 2I. They are going into a major stress. What can I do?
Awesome. And so there's a plethora of things that you can do. But first thing, if you're thinking it's lighting, I would dial back a little bit there. And then go through what we talked about today in this presentation. Look at the parameters that you have set, and then reach out to us. If all things are set there, let's reach out, let's talk, and see if there's any opportunities to elevate some of these areas that you're not looking at other than the lights, right? And so there's usually 9 parameters, including lights, when it comes to plant production. So, you know, it could be something where it's soil temperature. It could be something where, yeah, we have the nutrition that we need, but maybe we need it more often. And so the plants are using up what you're giving them at a faster rate than we're supplying them to the plants. So that there's a lot of key things we can look at. Temperature is huge. CO2. I can't tell you how many times I've gone into a grow where, you know, the grower thinks that he's getting 1,000 CO2. His meter says that on the environmental computer, and then when you go in with a handheld CO2 meter at Canopy, we're getting less than ambient. And so, you know, just double checking what the computer's telling you is huge, right? And so I think there's a place for you to start, and then if that doesn't happen, then we should reach out to us. We can more than well help you.
Could someone supplement with infrared to overcome the lack of it versus HPS?
Can you repeat that question?
Yeah. Could someone supplement with infrared to overcome the lack of it versus HPS?
Yeah, absolutely. I believe that, I mean, there's technology out there where you can add that infrared in there. We don't supply it in our light bars as of yet, but I'm sure growers can do that. But, you know, and also thing that growers need to take into consideration too is that the HPS, it's 1,000 watts, right? Our most powerful light is 631. And so that reduction in wattage as well will also contribute to the heat, because when you look at the architecture of an HPS fixture, it sits in a hood. The double-ended bulb sits in a hood. This hood reflects all of that energy straight down. So light and heat is getting pushed straight down into the environment. And so, you know, just supplementing with infrared would need a deeper dive to understand, you know, what's going on in terms of temperature manipulation of the plants.
Okay. What would you recommend the ideal temperature, as the graph depicts a slightly higher than usual temp for optimal photosynthesis? So what would you recommend the ideal temperature be for optimal photosynthesis?
For me in cannabis, I'm seeing great results anywhere between 70. Well, let's talk about that, right? So there's two different temperatures we could talk about. There's the area temperature and the leaf temperature, and I'll give you my optimums for both. I like air temperature to be anywhere between 80 and 85 max, and then my leaf temperature needs to be anywhere between 79 and 82. That's where I like to see leaf temperature under LEDs in cannabis. Granted that all the other parameters are optimum, such as CO2, water management, things of that nature. So hopefully that answered the question for that person who's talking about temperature.
Sure. So you mentioned cannabis-specific BPD charts versus traditional BPD charts. You know, why do you cap it at 85-degree temperature when some of these charts will show you can go above that with the right humidity in the room? So what is your reasoning of stopping at 85? If you don't mind me kind of narrowing down on that answer.
Can you repeat that your last sentence?
So just, you know, you're capping your temperature at 85 degrees. You don't want to see it go higher than that. When we look at some of these, I guess it's non-cannabis BPD charts, we're seeing that these ranges could go higher. I guess you're now saying there's specific BPD charts for cannabis, and is that what you're seeing with these specific BPD charts on cannabis at 85 degrees? That's really the max temperature you want to follow?
Yeah, so that's the thing, right? Let's not just cannabis, but let's talk about other flowering plants, right? And we'll talk about the flowering phases of plants. You want to promote a more generative environment for flowering, and we know that elevated temperatures can cause some detrimental things to flowers, such as delay in flowering, could cause a delay in development and growth of flowering, and so we're sure that there's cannabis plants that can take way higher than 85. I mean, there's cannabis that is grown full sun, dead in the middle of the summer in some hoop houses that don't have any fans, right? And so temperatures get really high in those cases. But what we're seeing in more controlled environmental environments is that you want to stay in this range because it's more conducive to, one, your bill. You don't want to be running crazy high hot temperatures because now your HVAC system is having to work harder to push temperatures really high. And then two, like I said, you want to promote more generative growth, and temperature really pushes that. You can see it in other flowering crops such as roses, chrysanthemums, poinsettias, that even with high temperatures you can get some really wonky responses. I've even seen or even had cases where temperatures that have spiked, and then we've seen the plants hermaphroditing, right? And so I'm not saying that all hermaphroditic responses in cannabis is due to temperature, but I've seen it in my experience when it gets too high.
Okay, great answer. I appreciate that. What is the maximum PPFD you would recommend? Have you done trials and found a PPFD where it gets too high and thus inefficient, detrimental to the plant?
Well, that's a really good question. And in my personal experience of working with my guys, I got cultivators that are pushing 1,500 right now, anywhere between 60 and 65 DLI, and having great success. But then I also hear cases where researchers and these professors from the university are pushing their plants up 1,800 and plus, and still haven't found the saturation point for cannabis when it comes to lights. So this is a question that I think we all are going to be looking forward to the answer to in the future. And I think we're getting pretty close to that because a lot of people are turning their attention in that direction. And so I'm excited to see where our research leads us, and then where, some of the growers that we work with, we can push light levels that high, But we also got to get to a point where we got to say, look, is this for my ecosystem? Is this conducive for my overall environment? Is this just one cultivar out of the many that I'm growing that wants all of this light or can absorb all of this light? So there's many questions to ask of a cultivator and a system operator to understand and really, hone in on the light levels that is appropriate for their crops.
And budget. These things aren't cheap to play with, as the more light you want to put into them, that's for sure.
Exactly. Oh, yeah, absolutely.
All right. As shown, CO2 is crucial for optimum photosynthesis, especially coupled with high temperatures. How do you combat the HVAC exhausting CO2 during times of high temp where high ppm is required?
Oh, so yeah, that's a good question, right? And it's hard, right? So, but you guys, I think growers need to, and I don't see it enough when I walk inside these grow environments, but these handheld CO2 meters, right? Checking what your computer is saying, say your environmental systems provider, you have an environmental control system that reads your CO2 and regulates CO2 for you as well, checking those, but then also going into the environment, because as we know, CO2 is heavier than air, so it'll fall and be closer to the floor. It's crucial to put those sensors or the meters, walk in there with a meter and check CO2 at the canopy of the plant, and making sure that what your system is saying that you're getting, and then working with a CO2 provider. I mean, there's ones where guys are getting, the 50 gallon tanks that are put in their room, and then there's companies where they pull up, like if you're pulling up to a propane station and getting a refill for propane, these big CO2 tanks that sit on side of the either the greenhouse or the indoor environment. And then working with them to make sure that, hey, look, at my high temperatures, am I still going to be able to maintain these CO2 levels? Is crucial.
All right. You state that there should be runoff with each watering. Additionally, you are stating that there should be multiple watering. What about if the substrate does not dry down enough between waterings to allow another watering with runoff? Sporty.
That's a great question. And so how can we increase that water uptake rate? There's a couple of things that we can do. There's temperature that can play an influence on that. There's the humidity that you're currently managing, and so making sure the humidity is low enough to allow for more water vapor to escape in the air is huge. And then the big one is to remove the microclimates that are around the surface of the leaf, right? And to do that is to push airflow and use convective energy as a source to push transpiration, right? So you have light energy, you have energy through temperature, and then you have convective energy, which would be considered airflow. And so making sure airflow levels are, I like to see, growers are saying 0.5, but I like to see 1 meter per second minimum and up there. And so pushing air through the canopy, making sure root health is optimal as well. Because if you don't have a root system that is healthy, white, with the hairy roots or the root hairs there, then you're also going to get a reduction in water uptake. So making sure all of those parameters are in sync and optimal should help you get different results in when watering or managing your moisture.
That's a great answer. Do you think that lower efficiency micromole full spectrum has a better effect on plant growth and resin than more efficient high red, low blue spectrum? Is this substantial enough to justify the extra cost and fixtures other than ease to work with for the eye?
Gotcha. And so this is comes now talking to what is the goal for the company, right? And so what's our portfolio? Are we producing shelf flower? Are we producing extracts such as rosin, live resin, things of that nature? And then let's look at the OPEX and the CAPEX of both of these systems, right? And so if your business is mostly to produce extracts, then yeah, I mean, of course, if your cultivars are showing that you're getting better responses from the low efficacy type of fixtures, then you have to make the decision that's best for the business. And so yeah, I would say that. But if we're talking about yield and quality of shelf flower, this plant cannabis has shown responses to these advancements in technology than more than any other crop that we've seen, right? And so that's the other question. So if you're producing shelf flower, craft cannabis for the consumers, it's important. It's important to get that light intensity in there because the ROI, I mean, yeah, you spend a lot up front for LEDs, but if the system is run really, really good and optimal parameters are set and executed, you can see the ROI on these things really be really short in terms of your return on investment.
Would you say LEDs pair well with organics or hydro?
Well, that's good. That's a good question. And so, I mean, I think they go really well in both situations. I got a grower we work with really well, T-God, as you all know, the green organic Dutchman. They are using living soil on a commercial scale, and they're doing it under 700 ppfd supplemental in greenhouse, and are doing a really good job from what I see. And then we also have customers that are doing hydroponics and doing really well. And so what I see that's key is not restricting the water uptake in each one of those media situations. And so in hydroponics, you already have the water there, so there's no restriction on pulling that water, but making sure that water is nutrient rich and can provide for the plant is important. And the same thing for the organics, because what's happening is that there's a communication between the plant and the soil. And under the high ppfd conditions, this communication between the plant and the soil will be elevated. And so making sure you have the right micros in place, the right nutrition in place, and making sure pH and EC are good so that there's no restrictions between the nutrition, then you will be fine. So for me, there's no difference in running it either under an organic or a hydro setting.
Okay. Is there an ideal height from canopy in flower under the Viper? So this is a great question. Really good question. And it's been a debate for so long that we say, 6 feet, 3 feet, 4 feet, what is the right height? No, we shouldn't look at it like that. We need to look at the crop and say, what's the right ppfd, right? So you can put a fixture that's 3 feet away that's getting, 1,200 ppfd on canopy, and you can put a fixture that's 6 feet away and is getting 1,200 ppfd at canopy. I think that metric is more important than the height metric. And understanding that and working with a lighting provider, a good lighting provider, they can provide that for you. Okay. What is the pour-through method to measure pH and EC you mentioned?
Awesome. And so, this is something that growers have been using for years and years, all across all different forms of agriculture and horticulture. But basically, what growers use, and this will be also in our cannabis cultivation guide that comes out in March to actually walk you through it. But it's essentially where you take certain milliliters of either deionized water or RO water, so water that's free of nutrients and salts, You make sure your media is saturated, and it should be saturated for about 30 minutes to an hour before you run this test. This amount of this volume of liquid through the soil column or the media column and collect that using using either a beaker or some type of measuring device, and then testing that that nutrient solution that came out of the bottom is what you would consider a pour-through method.
Perfect. Would you suggest to rise slowly the temperature up as you transplant clones to Rockwell cube? Because we transplanted clones to cubes under LEDs at around 80 to 82 degrees with a 70% relative humidity, and the root zone got too hot for them to develop, resulting in root rot. What do you recommend on the temperature for clones?
Got you. And so that's a good question. And so what we like to see early on in cloning is a elevated root zone temperature to, push the plants to make roots. And then once you leave that stage, we kind of taper off the temperature and push it towards a cooler temperature. So anywhere between 75 and 78 is ideal. And then with a higher relative humidity, gradually removing humidity day by day. So I would say around 75 to 78 is ideal for roots and then the transplant phase.
Would you recommend putting a heating mat under the clone dome?
No, but I would recommend using a soil probe temperature. And so I don't see this enough with growers. Me coming from a background of seed production, it was very crucial for us to understand the soil temperature for each different type of seeds that we were producing. And so I don't see it enough when I walk grows with growers, but it's a simple soil probe. It's one of those like a meat probe thermometers that you get off of Amazon or Google. But understanding that, using that to measure what your root zone temperatures are in the middle of the day, early in the morning, and then late afternoon is good to understanding your environmental as a whole. So I would recommend that for growers.
Okay. What is the point of under canopy lights, and are they worth the money for them?
Right. And so, there's a good study. If those who are listening want to go and look at a sub-canopy study that one of our senior scientist, Dave Hawley, he conducted at his time at Guelph on cannabis. So if you research that, you can look up and pull up a study on sub-canopy lighting and see what he got as his results. His things, I won't spoil it for you all, but it was promising. And so it's something that you would have to test in your environment, depending on how your production setting is set up. If you have benches or if you have gutter systems, depending on, if employees can, go in there and not damage the light. If you're, applying products to the plants that, can be detrimental to the light, that all has to be in consideration when making these decisions to add that in there. But I'll let you all look into that study to see and decide for yourself if it's something that you think is beneficial.
Sean, we're wrapping up here. We're down to about the last minute, and I want to give you a chance to kind of part with some closing words to our audience. So if you would, any kind of closing remarks?
Awesome, Ellis. I thank you guys for your time today and allowing us to present, what we're seeing in the field in cannabis and from Fluence's standpoint. We want to let you all know that we are here as a resource for you, not just a lighting company, but as a solutions provider. As you can see, we have a wealth of knowledge, not just in lighting, but in other facets of cultivation. And so we want to just work with growers, work with the systems providers to make sure that they're successful. Their success is our success, and we're looking at this journey together. And we want to be here with you all for years and years to come.
Well, I thank our audience for tuning in to Adjusting Your Environment, How Lighting Affects Cannabis Cultivation. Thank you, Sean Sangster of Fluence. I also want to thank Cannabis Tech for sponsoring the show. I'm your host, Ellis Smith. See you next time on The American Cannabis. Thank you.